Before we can program colours into a computer, we need to be able to describe colours using numbers. So there's several different ways of modelling colour using mathematics. Probably the most common used one on a lot of computer programs now is called RGB colour mixing. So RGB stands for red, green and blue. They are always in that order, always RGB. An easy way to remember it is that if we think of the colours of a spectrum, red, orange, yellow, green, blue, indigo, violet, they're always in the same order there, RGB. On this model, these are the primary colours for light. Note that that's different to the primary colours for paint, which would be red, yellow and blue. So to look at how this works, if we imagine that we were in a cinema and there are three huge spotlights at the back, all shining onto the screen in the three primary colours for light. The rest of the cinema is completely dark. This is what we would see on our cinema screen. So where the red spotlight is shining, we just see red up against the screen. We've got the green spotlight and we just see that pure green, and the blue spotlight and we see that pure blue. But where the spotlights overlap, we've got more light. We've got light coming from the red and light coming from the green, so we're going to end up with a lighter colour because there's more light there, more energy there. So the red and green together will make yellow, the green and blue together will make cyan, and the red and blue together will make magenta. Where we have all three colours of light overlapping, we'll get white, because we've got as much light as it's possible to get there, so we have the brightest possible. Where there isn't any light, we get black. So if you think about that, if we turned all three of these spotlights off, we would be sat in complete darkness, and it's as dark as it can be, so we get black as our colour. If we turn all the lights on, where they mix, then we get white. In the RGB colour model, red, green and blue are represented by an 8-bit number. So here, this is our 8-bit number. The question there was the highest number we can count to using 8 bits. Well, if we take the next 9-bit number, because these are all ones, and we work through our binary place values, 1, 2, 4, 8, 16, 32, 64, 128, 256. This is one less, so that's going to give us 255 will be our highest value because we are using an 8-bit number. That means that red would go from 0 to 255, but this actually gives us 256 different colours for that red channel because we've got to include the 0 even though it's black. It's exactly the same for green. We'll go from 0 to 255. So we've got 256 different numbers there. And then the same for blue, 0 up to 255. If we take a look at this in a desktop publishing package, we've got our RGB sliders here. So at the moment, all of those are set to 0. So we've got black because there's no light there. So if we turn the red completely up to full, then obviously we see red. If we mix in green, then we get yellow. Now our RGB number is 255, 255, 0. If we mix in the blue, we get white, and the RGB code for white is 255, 255, 255. If we just put them all back down again, we can see that our RGB code for black is 000. Then let's look maybe just at the primary colours themselves. So red will have a colour value of 255.00. Green, colour value of 255.0. Blue, a colour value of 255. Usually when we're using colours, we would mix combinations of these to get the different colours, but for the time being we're just sticking to primary and secondary colours. So if we go back to the PowerPoint and take a look at that, we've got our 3 primary colours around the outside, and then where 2 primary colours meet is where we have a secondary colour. So up here in that red circle, the RGB code would be 25500, because red always comes first, green always comes second, blue always comes third. Our RGB code here would be that we'd need all the red, 255. There is no green because the green finishes there, so that would be 0 for the green, and we've got all of our blue, so it would be 255 for the blue. So our RGB code for magenta is 2550255. Again, in the middle, like we just saw in the desktop publishing program, white would have an RGB code of 255 255 255. So use this information and answer the questions about RGB codes. If you can't print out the questions, then just draw the table on paper and answer them that way. If you need to rewatch the video, and that will help you with your answers to the questions.